Are we out here? I think so. Can you hear me? Well, first of all, hello. Thank you for stopping by. My name is Matt Bartsch. This is the proper day one to programming, to becoming a software engineer. Let me pop these headphones on real quick, just a second. So this is me kind of monitoring the stream. Okay. Sounds okay. Alright, I think we're good to go. Awesome. Okay, I was like waiting for the delay. Couple things. First of all, I apologize for the time that this is happening. I said in the last stream that I would be doing this on the 25th. September 25th. And it is not the 25th. It is the 26th. My time. And I was intending to well, you know, okay, let me put a pause on this. When I went live the first time and did the whole bit, like the last part where I went to this screen, the one you're looking at now, obviously it went quiet. But I think you should hear, you can, I was like, you should be able to hear me now, but I just listened to the stream and you can't hear me, so that's good. But I apologize for it being quiet for the first stream. I'm glad it wasn't a bigger chunk of the video, but it is fixed now, so that's good. But so I can't remember if I said this during the first. I can't remember if I said this during the first stream or not, where you could hear it. But I mentioned doing the day one of the stream, like properly getting into the programming, on the 25th, and I was intending to go live on the 25th, but reasons happened and we're doing it now. It is early on the 26th, but so I apologize for that, but here we are. So without further ado, let's get into this. All right, here we are. Yes, I have yet to activate Windows. I'd like to. I'd like to at some point, but money is, it does not grow on trees. But let's see. For now, I'm going to leave that up. I'm going to leave that up. But let's kind of take a look here. Week 1 to introduction to Python. We're going to try and understand the basics of Python programming. Day 1 and 2. Start with Code Academy's Python course. We're just going to use that link. This interactive course covers Python fundamentals and is great for beginners. That's it? No, like YouTube or anything? Fair enough. Cool. Apparently, approximately this is 25 hours. Apparently, this is approximately 25 hours. Start. Hello world. I wonder how that became like the thing that programmers do. Like starting off. Hello world. Python is a programming language. Like other languages, it gives us a way to communicate ideas. Okay, so programming language. What's this? Oh. Files are named locations on disk. Am I thinking too hard about this? Yeah, I think so. Change Codecademy to your name in the script. In the right. Run the code to see what it does. Oh, this is going to be awesome. I like this already. As soon as you're ready, move on to the next exercise to begin learning to write your own Python programs. How do we run it? Oh, run. Okay, here we go. I'm telling you, we're doing this. Matt. Print hello and welcome plus my name. Okay, so I was going to say hello and welcome, Matt. Hello and welcome, Matt. Cool. Want to quickly review some of the concepts you've been learning? Take a look at this cheat sheet. I mean, so you just got here. Are there going to be any? Oh. That's a word. Concatenation. Okay. Here's some helpful links to the top questions asked by coders about this exercise. Why do I need to enter my name on a... Wait. Whoa. I'm sorry. Why do I need to enter my name on a different line? How can I use an integer in a print function? Won't we get to that? Like, why is it getting asked now? Let's just hit next, right? Let's not think too hard about this. Comments. Ironically, the first thing we're going to do is show how to tell a computer to ignore a part of a program. Text written in a program but not run by a computer is called a comment. Is that across the board or just in Python? That's my question. Comments can provide context for why something is written the way it is. Ignore a line of code and see how a program will run without it. Oh, how it says like useful value equals old sloppy code, useful value equals new clean code. Instructions. Can I click it? I can't click this. Documentation is an important step in programming. Write a comment describing the first program you want to write. Comment. Or hashtag. I want to write a program that I don't know. Tells you what superpower you would have. I don't know. Hey, dude. Obviously nothing came up because we commented it out. Why is there no output in the terminal? Because we commented it out. Is this the terminal? I'm assuming this is the terminal. Because I know that we have, like, terminal down, you know, we can, like, properly bring it up. I'm assuming this is terminal. But we're going to hit next. Print. Oh, this is so good. I'm enjoying this. Now, what we're going to do is teach our teach our computer to communicate. The gift of speech is valuable. A computer can answer many questions we have. Python, the print function is used to tell a computer to talk. The message to be printed should be surrounded by quotes. This is interesting. From Mary Shelley's, Frankenstein print, there is something at work in my soul which I do not understand. In the above example, we direct our program to print an excerpt from a notable book. Oh. So, I didn't know it was Mary. Is that a different... Do I just not know who wrote Frankenstein? Like the OG Frankenstein? That might be the case. I mean, that is the case. I don't know who wrote it. I didn't know it was Mary Shelley, if it was. The printed words that appear as a result of the print function are referred to as output. The output of this example program would be there is something at work in my soul, which I do not understand. Print the distinguished greeting, hello world. Gladly, print equals, parentheses, no, where are these? Shoot. I don't know what these are called. I know these are parentheses. Anyway, I'm sorry. It's like 1:45 in the morning right now. Hello, world. Run. Wait. What'd I do? Is it space sensitive? What? Print equals, right? Did you... Is it like single? Let's see if this will fly. I know this will fly in like real code. Like in a real text editor. What's going on? Print equals. What if I just copy and paste? Surely it wouldn't include... It's literally print equals. That's literally what it says. Oh my gosh. I did print equals. Hold on. I need to do this right. I was all caught up on the what was in the yeah. Let's try this again. Hello world. They should be good. Yep. Crud, man. We're 3 pages in. I had to stink in. Oh well. Learn the basics of Python 3 is one of the most versatile. Oh no. 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 Bro. Okay. I'm curious. How much would it be? I know I want to do things free. Chat GPT doesn't always get stuff right. I guess this is a part of it. Is this like a subscription-based thing? Pricing. Oh, that's not bad. Oh, but it doesn't have all courses? Oh, plus. I'll be honest, that is disappointing. I'll have to think about that. Okay, so we'll need to put Codecademy on the back burner for now. Continue with Codecademy. So it wants me to continue. Okay then. Well. So I'm going to need to think about Codecademy or Zero to Mastery. I'm going to make the decision off stream. Can we just pull up a Python one? Is there like a... See, I love this though. Man, but Codecademy is pretty good too. There's no like preview. That's a bummer, man. I mean, that kind of serves me right for just putting all my eggs in one basket, i.e. ChatGPT. What's the trial like? 7 days. Okay, so since Code Academy is not really, kind of did all we could on that for now. I'm curious. Free code camp. Okay. We might pull an audible here. Oh, that's another free code camp. Free code camp. Free code camp. Yo. Okay. So I'm thinking, I think unless I missed it, Code Academy, this is the only thing for Code Academy course. So I think what I'm going to do, right, I think what I'm going to do is, we're going to switch over to free code camp for Python. And we're just going to do this like the Code Academy one. And we will start over. Because I want to do everything free, and I want to, I mean, as much as I can. Like, if push comes to shove, I think, I said I was going to make the decision off stream. I might go with Zero to Mastery if need be, but that's like months down the line. So, man, I mean, I am bummed about Code Academy, though, because that was really helpful. But for now, we are going to get into free code camp, and I'll just think about Code Academy and Zero to Mastery and whatnot. So let's we're just gonna watch this. I have I'm sorry. Okay. Yes. I've already downloaded Python, obviously. And I have Visual Studio and stuff. So we're going to I'm all like double thinking, second guessing everything now. Cause like I was vibing with Code Academy, man. Whoops. I mean, maybe that's all it wanted us to do. Yeah, forget about it. We're going to stick with this for now. Don't want to throw in the towel just yet and pay something. We're going to start with this. We're going to watch a video and we'll work through these. Sorry I've been so back and forth. I didn't realize what was going to happen with Codecademy. But we're going to stick with this for now. Just going to kind of pivot as need be. I know this is free. And so we're going to listen to them. Spoiler, the answer is everyone. Yeah, here we go.
Hello everybody and welcome to Chapter 1 of Python for Everybody. I'm Charles Severance, I'm your instructor, and I welcome you to this class. The basic goal of this class is to teach everybody how to program, regardless of your background. You don't have to be a math whiz, you don't have to be a computer expert, no matter how old you are or what your background is, we want to teach you how to program. So welcome to the course, welcome to Chapter 1. So the first thing to understand is that the purpose to learn to program is because computers want to do things for us. They are built and created and designed, and their hardware is set up so that they basically ask us, what do you want to do next? If you grab your phone sort of does nothing until you tell it what to do. It waits for you. And it's just waiting for you, and all the hardware, computer technology around you is generally waiting for you. And we can use this for useful things. We could play video games. We could have it help navigate for our cars. Someday we might even have self-driving cars. And it's really, in a sense, in my mind, silly if you spend your whole life not really understanding this technology. And I think it's important that we learn to tell these computers what to do rather than just let them increasingly control our lives. And so, as we'll see, computers aren't very smart on their own. We humans are the ones that imbue them with knowledge, but we need to learn to speak their language. It is much easier for us to learn to speak their language than it is for them to learn to speak our language. Although, with these cell phones, we're starting to see little bits where they can begin to understand, but you would be amazed at the 40 or 50 years that has taken us to understand how to build programs to begin to understand. So I'm bringing you into something where you are going to learn the ways of programming and the ways of the computer, because it's easier to teach you how to program than it is to teach this how to work in your world, even though ultimately the goal is to get this to do work for you. So part of what I'm trying to do is move you from a user perspective where you just look at the computer as something that someone else has constructed and you are the user of, to the point where you construct new things. Now the first kinds of things that you're going to construct are actually things to solve your own problems. And it's very popular now to work on data, and Python is an excellent programming language for data mining and data analysis, and that's a lot of what we're going to do in this course, although really it's a gateway to all kinds of things like, artificial intelligence or gaming or navigation or mobile applications or entertainment, all kinds of things. But first we have to learn to program. We have to move from using the computer as a tool to using the tools within the computer that allow us to change how the computer sees the world. So there's a couple of reasons that you might want to be a programmer. Some of you are looking to improve your career, to be paid to work on programming. I've been a paid programmer most of my life, and I like it. It's a good job. You don't have to stand in the mud. You don't have to lift things. You have to use your brain. And I'll just say that it has been nice for my career to not be exposed to the elements, but to be able to work often wherever I want. But that's actually our secondary goal. Our first goal is to get you to write programs that solve problems that you have to solve. Maybe you have a job as an accountant or a lawyer or something else, and maybe you run across some data. Maybe there's some system that logs your time and it's not quite giving the report that you want to give. And so you say, could I just grab the log data myself and write a program to do some analysis to say, oh, what's the average this versus that, or the average of some other thing, right? And so that's the basic idea, that you'll initially use computers to serve your own ends. That makes it a lot easier to write programs because you don't have to worry about, you know, a million users using your software. If it works for you, then we're happy. And so it takes a little more training to write software for other people or for thousands and thousands of other people. And so part of what I want to do is I want to change your perspective. You know, you look at this from the outside and you see it from the outside and you click on things. I want to turn this around, and I want you to be the person inside this looking out at the world. And as a programmer, we are making things inside these computers for the world. And so we want to pull you into being part of this. We want you inside this, or thinking inside this. And what you learn is that if you're inside this computer and you are taking your instructions to build programs to be used by the human, oops, almost dropped that, the human outside the computer, you have things that you need to take advantage of. There's things like the central processing unit, the memory of this system, the network connection of this system, the disk drive or permanent storage on this system. And as a programmer, you are kind of mediating between all those internal resources that this has that are not very smart but highly powerful, and mediating with what that user wants, right? And so we take the end user, and we programmers, we serve the end user, but the computer serves us. So together, between us and all the computer's resources, we can serve the needs of the end user. And we do this by writing code or programming, okay? And what is that? Well, programming is a sequence of instructions where we are giving instructions to the resources inside the computer in a way to accomplish the goals of the end user. And remember, sometimes we are our own end user. It's not just you know, you're not always doing a startup, you're not always writing a mobile gaming system. Sometimes you're writing something for yourself, but that's okay. So sometimes you're writing something to solve a problem. You're like crafting, you're doing something that you could do by hand or manually, and you're making some clever little 25 or 100 line program, and you're putting that in. Other times, like when I work on the open source learning management system Sakai, it is my creativity. I've got an idea and I want to share it with a million users, and so I write my code for an external audience. And so code is that sequence of instructions that the computer itself doesn't know how to hand a roster out, but I can write code that will hand a roster out by looking at the data that's inside this computer, inside this application. And so if you think about programs, we have programs for computers and programs for humans. And a number of years ago, now I'm starting, sooner or later this will be me showing my age, this is an example of the Macarena. And the Macarena is a song that effectively is a sequence of instructions. You put your left hand out, you put your right hand out, you put it on the shoulder, you wiggle, 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 and you spin around and you do things. And this is a program for people. And so I want you to take a quick look at this and see if you can find anything wrong with this particular program. So look really closely.
I'm going to pause this really quick. I apologize. I didn't really do anything, but I was listening on the stream. It was a little loud, so I turned it down. Hopefully the video audio is a little more bearable now. Yeah, so he wants us to look at this. Left hand out and up. It's this part right here. I say that because I remember, but honestly, it's supposed to be hip, right?
So I'll show you.
Oh shoot! I hope this is copyrighted
It's
music.
got
I
some
didn't think about that.
typographical errors in it. And we as humans
Oh,
are
that too.
really good at reading or hearing typographical errors and correcting them automatically and instantly. And but computers are not. Computers are extremely literal. If it saw this ham instead of hand, it would think, what's a ham? And why am I going to hit someone in the back of the head with a ham? And why would I take my left hand and hit somebody? That's, these are all bad things. But the computer is going to take us very literally. And so we have to be really precise. And the computer just doesn't know the difference between what we mean and what we say. So we have to be very precise. And this is one of the great frustrations that people have when they first start using computers. And so we have to get this right. We have to get these little bits of text exactly the way they are. Computers will blow up with syntax errors, and they seem to make quite a fuss when you make the tiniest of errors. But you'll get used to that. I mean, that's not because you're bad or you're less than awesome. It just means the computers can't compensate when you make small mistakes. And so you got to get used to the fact that the computer is sort of intellectually not as strong as you, and so it gets confused really easy. Even though when it gets confused, it says seemingly mean things to you. So you'll get used to that. Okay, so the first thing I want to do is I want to throw up some text, and I want you to, while this text is up, I want you to count the number of each word in this text and tell me what the most common word is in this text. Okay, so here we go.
Crud. I'm gonna mute this. Just in case. When he pops up on the screen, I'll bring back the audio.
Okay, so I kind of made that hard on you on purpose by moving it around and distracting you and confusing you. But even if it's not moving at all, it's a little bit, tricky to do. You probably stare at it a couple of times. Your brain is going back and forth and back and forth. And so text analysis is one of the great things that computers are very, very good at. And some of the things that, they can translate text, and that's because they've looked at a lot of information. So looking at text is actually something computers are really good at. And so if we take a look at the kind of programs that we're going to write to do this kind of thing, this is something that humans are not naturally good at, but computers are super good at. Now, I'm not going to have you look at this code. This code you will understand in a few weeks, but basically this is a set of instructions to open a file, read that file, read all the words in the file, create a histogram of all the words in the file, and then search through that histogram to find the most common word and tell us what the most common word is in the file. And in this clown file, the word the is the most common. It happens 7 times. And here's another large file called words.txt, and the word to is the most common thing. And our goal is to get to the point where you can write this on your own. So you can say, you know what, I got a problem to solve. That is, what's the most common word in this file? I know how to start, and then I know how to finish. I know how to do the stuff in the middle. And we have to learn this kind of weird language, but when we do, we can count millions of words as easily as you count 20 words. So that's the fun of all of this, is to teach you this language so that you can solve that problem so that you don't have to solve it. Because you could solve it, but it's not something that you're naturally good at, and it's hard work. So up next, we're going to talk a little bit about the hardware architecture that you're going to be experiencing as you write programs.
Okay, so that is the first one. So I got 2 days here. We're probably going to continue on. Dang, so this doesn't have us come back to the Codecademy thing until like a week? No, it'd be like 2 weeks from now. We might sprinkle this in as we go. I want to check something real quick here just so I know. Ooh, does it give us a number? Oh, it does. So when do we want to finish this? Well, because we got 2 months, right? Roughly. Thereabouts. But it's not the only thing that we're going to be doing. Let's try and do... We'll do more today. How long have we been going? How long? Bear with me here. How long? Doesn't tell me? It does tell me. Wait, does it? It does not. About 45 minutes thereabouts. Okay. So we'll do more than 2 tonight, but we'll probably try and do oops. Probably about yeah. Probably about 3 a day. 3 a weekday. I like that idea. So let's keep chugging. Check your answer. See, now it's like 25%. This is how far I've gotten. So I'm 25% done with this right now. But if you're just starting off with me, like following along with me, it's not going to say 25%, but fear not. That's just, because it's the first one. So he's just going to talk about like hardware. I don't know how much we'll actually need to see this. Need to know this, but I mean, it's not bad stuff to know. So here we go.
Hello and welcome back to Hardware Architecture. Now you might ask, why do I tell you about hardware architecture? You're not probably you're not going to build any hardware, although it's fun stuff to do. And if you're going to become a computer scientist, which most of you won't want to be, it's a great thing to study. And those who build our hardware are amazingly talented individuals, and it's a really rewarding job. The reason I like talking to you about hardware is because I want to be able to use words at some point and say, oh, secondary storage, or central processing unit, or random access memory, or peripherals, input devices. And I want to be able to say those words, and I want you to be able to understand them. And so I'll start with a little piece of hardware called the Raspberry Pi. And the Raspberry Pi is a cute little single board computer. As we go forward, these things are smaller and smaller and smaller. And the interesting thing is that the architecture of these stays the same, but the number of components drops. So I'm going to start and give you a block diagram of sort of a generic computer and tell you the major parts of it. Now, I'm going to show you some really old hardware, some really new hardware, and then some hardware that is of medium age. And the medium age hardware is probably the easiest one to see. The architecture is the same, okay? And so the basic block diagram is that the brains, if there are brains in computers, which there really aren't, the software is the closest thing computers have to brains, but in hardware, the closest brain a computer has is this, called a microprocessing unit or a central processor unit. And this is designed, 3 billion times a second to ask the question, what do you want me to do next? And these little pins on the back are our instructions, like 32 or 64 of these pins. 3 billion times a second, we send an instruction into these things. Now, we can't sit there and talk to it. We can't. And so the instructions we store in what's called the main memory. And this memory is really fast. And the memory sort of feeds this. And so every time the CPU needs a new instruction, it asks the memory where that instruction is. And so the memory feeds the instruction to the CPU does it, says give me another instruction, CPU does it, gives me another instruction, and that is the basic essence of programming. This asks what's next, and this is where your program is stored, or a program you purchased or came with your hardware, where that's all stored, and those are your places. And so you end up inside, your programs end up inside this memory. So then there's so in software you tend to program the CPU. And if you had bought a desktop computer a number of years back, it would have this thing called the motherboard. And the motherboard is called this because it kind of connects all the components together. And so if you buy memory by itself, it does nothing, but it has a place to plug into the motherboard. And if you buy a microprocessor, it has a place to plug into the motherboard. And if you buy a hard drive, this is a really old hard drive, it has a place to plug in on the motherboard. And so the motherboard sort of connects everything together. The hard drive is secondary storage. Now, the way how secondary storage is different than the main memory, which there it is. I got unpile this stuff. So this main memory is really fast, but as soon as you turn the power off of this memory, it sort of vanishes. And so to store files like word processing files or text files or whatever, you got to store it on something that lasts a little bit longer. And so that's the purpose of the secondary storage. It's permanent. When the power's off, it stores it. Now this one here is in such bad shape that isn't probably storing anything, but it's got these little heads and it spins around and goes in and out. And we'll have a video later that shows you one of these things that's not quite in as bad a shape. If you look, this has 4 different platters that are all spinning around. And so this is just using magnetic material and electronics that sort of magnetize and demagnetize this stuff. And if you look at a disk, they're often rated, physical disks are rated in revolutions per minute, and that's how many times this thing spins around. And if you got an old desktop and you hear it spin up, this is the thing that's spinning. And it's the place that your operating system lives, your files live, your applications live, while they're stored and while the computer's turned off. And then they're loaded into this while they're running, and then this CPU takes the data from the main memory, and your program runs at 3 billion operations per second. So let's talk a little bit about something that this is probably from the 1960s or 70s. This actually has, if you're an electrical person, it has capacitors. Those little silver things are capacitors. These little colored things are resistors, and that's more capacitors. And then there's wires. And wires move everything. And so when you say like this has millions of transistors, oh wait, that isn't a capacitor, that's a transistor. That's a transistor. When you say that this here has etched, and if you look closely at this, go look at a picture of a microprocessor online, you will see that it has millions of these. And so the difference between 1960 and today is this circuitry of capacitors, resistors, and transistors has been microized and put onto this. It's using a photographic process, and they're tinier and tinier and putting more and more on. And if you think going from millions of these to one of these is crazy, the thing that's happening now, and the reason we have whole computers inside our pocket, is that everything, all of this whole thing, CPU, memory, everything, all of it connected, and the storage is being made smaller and smaller. And so this little single board computer called a Raspberry Pi has one thing in it, and it has the main memory, and it has the CPU, it has connections for things like peripherals like keyboards and stuff. Now it doesn't yet have secondary storage on it. The secondary storage gets plugged in right here via USB. And then if you take it one step farther to my phone, it's got the secondary storage built right in. And so, you know, this picture goes from the size of cabinets in the old days all the way down to really tiny. But at the end of the day, inside it is a highly sophisticated piece of circuitry that asks for instructions one at a time, and main memory that holds the instructions and feeds them. Okay? Central processor does the thinking. Let's take a look here. Central processor does the thinking. It runs the program. It's asking what's next. It's not really smart, but it's really fast. And so we compensate for the lack of intelligence of this thing by us writing really good software that runs really fast. And so voice recognition on things like phones is possible because computers have so much storage and they run so fast, and the algorithms that do voice recognition are finally starting to work. Input devices like keyboards and mice and pens and whatever, they come in. Output devices are like the screens that we see. The main memory is the fast part of the computer that stores all the programs, and the secondary memory is the permanent storage. Increasingly, secondary memory, do I have any USB sticks in here? I don't. Well, increasingly secondary memory is flash RAM or static RAM with no moving parts, and so you, in a few years, you'll not even be able to see secondary memory with moving parts. But that's okay. It's still secondary memory. It's still memory that lasts. And so you, and where your place is in here, is you live in the main memory. This is you. You are here. And so, in a sense, when the CPU asks the question, what next, it is your job to answer that. And you answer that by writing Python code. And so your Python code, you'll write a file in Python code, blah, 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 blah. And then that Python code sort of gets loaded into main memory. There's a magic translation process that happens. And then your code is actually answering this question 3 billion times a second. 3 billion times a second, you're sitting there. But this is you. You're really out here, but you then write a file, and the file's loaded in, and then the file runs. And that's how things are at. And that's your place in the world. Now, what's actually running is not Python code. There is, as I said, a translation process. You write a Python file, and then Python itself translates this into the actual language known by the microprocessor, which is a series of zeros and ones called machine language. Someday I would love to teach you a class on machine language, but for now we're going to teach you Python, and we're going to use Python as a crutch. We don't have to talk machine language, but you could, if you really wanted to, you could know how to write machine language. But I assure you, Python is far easier to learn than machine language. So Python acts as a translator, translates what you're doing into machine language, and then the machine language is what's sent back and forth. But still, even though it's translated to machine language, it's you. It is you answering those questions, and that's what a program is you pre-storing your response to the what next question over and over again. So here's a couple of videos that you can look at on YouTube about a CPU. These CPUs, and it looks very much like this CPU that I've got with me, these CPUs have extremely high heat. When you put this thing, or your computer, on your lap and it starts to heat up, that means it's thinking really, really hard. And so this is a small little old video from a long time ago that shows what happens when you take out the cooling capability of microprocessors and just how hot they can be. And the other video that I have is a hard disk, something like this hard disk that I have, except that it works and they turn the power on. Some of them last for a few seconds, some of them last for a few minutes. It's never I must be allergic to this hard drive. Or maybe it's because there's dust in this hard drive and I keep spinning it and I sneeze. But 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 basically, some of them last for a few seconds, some of them last for a few minutes. It's not a good idea to open them up, but I'm glad somebody opened it up and then did what they did and then recorded it so we can all enjoy what it is that they're capable of doing. Okay, so that's a quick introduction to hardware, mostly so that I can use those words going forward. Now what we're going to talk about next is communicating in the language Python, that is, writing code and putting it into the computer so that that can execute. Okay?
Okay. So, where are your programs stored when they are running? Not a hard drive. Oh man, I'm going to get this wrong. Hey, I got it right. Oh dear. Okay. Okay, so this is going to be our third one. I think this is going to be our last one for today. Just so everybody kind of knows. Although, also, I want to mention this as well. If you're in the chat, hello, feel free to comment, and I'll respond to you. After the, down the road, if there's like way too many comments, won't be able to respond to everybody. But right now, I see that there are 2 people watching, so hello. It's probably like I'm one of them because I've got the stream up on my secondary computer. The second one's probably my wife, so hello, my wife. But yeah, let's get into this third video. This one's not as long.
Hello and welcome back to Python as a Language. You'll notice that I'm wearing a hat. Part of the story of the hat is that where I work here at the University of Michigan School of Information, my office is in this building called North Quad, and we call it quadwarts sometimes because it's sort of got a square. It sort of imitates an Oxford quad, and so it seemed to me to evoke notions of Harry Potter. And when we first moved into the building, I joked in one of my classes that we should have a sorting ceremony for all the students as they come into North Quad for the first time. And so that was cool, and I thought that I would belong in Gryffindor, like everyone wants to be in Gryffindor, right? They're the good guys. And my students told me that I couldn't be in Gryffindor, that I had to be in Slytherin. So you'll see me drinking tea throughout the course out of this teacup. It's my Slytherin teacup. I picked that up from Harry Potter World. I went down to Florida and visited Harry Potter World. And the reason that I was sorted by my students into Slytherin is also because I teach Python. And Python is like a snake. And so if you think about the people from Slytherin, they are capable of talking to snakes. And the class that we were doing the sorting was a Python class, and so it sort of made perfect sense that you would have to be in Slytherin if you were the Python teacher. And of course, your name is Charles Severance, and then that sounds kind of like Severus Snape, and so I just accepted that I'm in Slytherin, okay? So you all can be in Gryffindor, but I can't. I'm in Slytherin. So I'm the bad guy. Or the good guy, depends on how you look at it, right? And so what I'm going to do now is I'm going to, bring you into Slytherin as well, because I'm going to teach you the Python language. Python is the language that we Pythonistas talk. It was invented about over 20 years ago by a fellow named Guido van Rossum, and away we go. Now, even though I'm using this whole snake Slytherin thing, it turns out that Python was not at all named for Harry Potter, because Python was invented, almost 2 decades before Harry Potter was created, and it wasn't for the snake. It was actually Monty Python's Flying Circus was the inspiration for Python, the name Python, and because Guido van Rossum really wanted to create a programming language that, while it was powerful underneath it in its very nature, was a very powerful language, he wanted it to be a language that was fun. And he wanted it to be a language that was approachable. And so that's why Python recently has become so absolutely popular. It's easy to learn, but it's also powerful, and that's sort of the magic of Python, is the ease of learning it, the brevity of the programs, the shortness of the programs, and the power. And so we are going to become Pythonistas. Now, as you learn to be a software developer using the Python programming language, you are going to encounter syntax errors. And I remember when I used to get syntax errors, and I remember my first programming class, and I would type on cards. And I would upload those cards to the computer, and the computer would say, "You're not worthy." And I'm like, wait a sec, those are pretty good cards. How could you be so critical of me? I'd say syntax error. And I really got sort of a really bad attitude that somehow this computer didn't like me, and that I would make cards, it would complain, and I would make changes to the cards, and it would still complain, and I'd make changes, and it would still complain. I'm like, how can I win in this situation? And you're going to feel the same thing. You're going to absolutely feel the same thing. You're going to be struggling. You're going to be like, how come this computer hates me? Let me assure you right now, the computer doesn't hate you. The computer actually loves you. It just is not very good at showing how it loves you, or telling you how or why it loves you. And so syntax errors are not so much Python telling you that you're bad, or that you're an inadequate programmer, or you should find something else to do. It's really Python's admission that it doesn't understand what you're trying to say. And so you got to get used to that. And it's frustrating, but you got to get used to the fact that syntax errors are your friend. Python is saying, hey, I got to line 7, and I was doing fine up to line 7, but boy, in line 7, there's some little thing. I don't know what the word else means in this context, or you didn't indent it, and so I'm kind of confused. What did you mean? Please, please, please help me. And so it's so much easier for you to learn Python than it is for Python to figure out what you mean when you're writing code. So we have a number of different ways to sort of encode our instructions when we talk to Python. One is we just run Python interactively on our computer. Hopefully by now you've got it installed, and you just type Python at a command prompt. So either a Windows command prompt, or a Linux command prompt, or a Macintosh command prompt. And I got some examples of how to sort of get this all started, get Python installed, and away you go. Now you'll notice when you run the Python interpreter, the 3 chevron prompt, Python is asking you what next, right? This is you, it's saying, I want to talk to you, I want you to tell me some Python to do. If you know the Python language, you know what to say right here. Now if you know Python, you can type these languages. You can say, oh, x equals 1, which really means go find a little piece of memory, label it x, and stick 1 in it. Print x is like, go find that thing where you labeled it x and bring me back that number and tell me what I stored in there. Now why you want to do this, that's a different question. These are very simple things. It's going to take you a while to get the big picture of why we're doing this. So just trust me that you want to learn these statements, and then later we will successfully turn those into a program. So x equals x plus 1, the third line there. X equals x plus 1 is not as it seems in math. It basically says, hey, go grab the old value of x, add 1 to it, and stick it back in x. That's what that means. So an equal sign really has kind of an arrow to it. And then we say, hey, go look up that x thing that we just did and print that out, and then we're going to say quit. So that's us talking to Python. Now, you can type just about any crazy stuff you want in here, and Python will be unhappy and talk to you. So what we're going to do next is we're going to start talking about the actual language of Python and what it is that we have to say to make Python happy when we're talking to it.
Okay. So I need to not say that after every video. Okay, so x equals 6, print x. You know what? Just for the sake of learning, come bring up Visual Studio Code here. So you guys don't need to download this. It's free, Visual Studio Code. But if you want to, feel free to download it. I'll let you guys figure out how to download it. I'll be honest, like I'm sure I just kind of Googled it. I mean, I think I had to like just Google it or something. Like it's not, it's not rocket science. But I mean, you know what? No, I'll help. I'll comment. I'll leave a comment or something in the description or something with a link to where you guys can download Visual Studio Code, and you can get this yourself. And then boot it up. Say new text file, or no, new file, I think. And then pick Python. It's going to want to know what language you're writing in. You're going to want to say Python. And I will say you'll need to download Python 3, and he'll help us do that. So we won't worry about that now. But for now, he'll tell us what that means too. But CLS means you can clear your CRUD here. So just for the sake of this, I'm really going to try and learn this here. So x equals 6. Print x, which is going to be 6. Spoilers. Run. Wait a minute. Oh. I got caught up in like this, in like the teal looking stuff, but it actually did 6. It did it right. So if we do it again, yeah, there's 6. 6. Boom. All right. So the next one we're on, we'll just hit it, ask me later, is repeated steps. Is that the one we're on? Like, I hope that me being kind of ahead for right now, I hope that's not throwing us off. So bear with me here. Let me check something. Were we on 3? No. Whoops. We're on 4. Yeah, no, we're right. We're on course. So, let me do this here now. Boom. All right. So, still kind of working out kinks on the whole on streaming and learning. So forgive me, but yeah, the Codecademy thing threw a kink in our plans, but that's all right. We will roll with the punches. So tomorrow, we're gonna be trying to do this every day. It's good to be consistent and you know, put in the reps, as it were. So we're gonna be trying to do this every day. Feel free to tune in. Please like and subscribe if you want to. But thank you guys so much for watching. I'm gonna be wrapping this up, but yeah, just to kind of reiterate the gist here, we're going to be going through 3 free code camp lessons, if you want to call them lessons. We're going to be doing 3 of them a day because we're going to be trying to crank through this in a relative time frame to what our schedule wanted, as far as getting it done in like 2 months. I want to get done earlier than 2 months though, because I don't know what the rest of the plan like has in store. And so three a day during the week. Won't do anything on weekends. But yeah, we'll need to take some extra time on certain videos. I just know from experience, from what I've done so far. I haven't even done all that much, but I know that like we'll need to kind of camp out on some stuff sometimes, and certain things will have exercises that we'll need to go through as well. There's gonna be some time. But that's okay. I'm in this. So, thank you guys again so much for watching. I'll catch you guys tomorrow. It will. I mean, I would like it to not be 1:30 in the morning when we do these. But we will see. But yeah, leave a like, leave a comment if you want. Leave a prayer request if you want. That's another thing. I'm a Jesus guy. Love Jesus. Love to be able to pray for you guys. So leave a comment for that if you want as well. And I will catch you guys tomorrow.